Okay, this question asks, suppose P3x is a Taylor polynomial of order 3 centered at a equals 1 and compute P3 2. So, okay, it's Taylor polynomial, so that means f of x is equal to 1 over x, which is, not f of x 2, but we know that f of x is 1 over x, which you can write it as x minus 1. And if you remember your Taylor polynomial, it's always like f of a plus f of prime of a, x minus a, plus f double prime of a, x minus a squared over 2 factorial, then f triple prime of a, x minus a cubed over 3 factorial. So this is what we wanna find. P3 of I'm gonna put it as x for now. Okay. So f of a, which a is 1, so f of 1 is equal to just 1. So that's 1 plus. So let's find the derivative of f, so which is f prime of x is negative x minus 2, which is negative 1 over x squared. So f prime of 1 is negative 1. Okay. So 1 plus, I'm going to just change plus into negative. 1 minus 1, x minus 1. Okay. Plus, we want to find the f double prime. So let's do that. F double prime of x is 2x negative 3, because negative 2 comes down and subtract 1, so 2x minus 3. So f double prime of 1 is just 2, right? So this becomes 2 of x minus 1 squared over 2 factorial. I'm just putting a value for 1 in here, and then plus, let's find the triple x. F third derivative. So third derivative is negative 6, x minus 4, and f triple derivative of a is, it is a, but I'm going to just put 1. 1 is equal to negative 6. So it's plus, so it's going to be minus 6, x minus 1 cubed over 3 factorial. Okay, we have that. So let's simplify a little bit. So 1 minus x minus 1 plus 2 factorial, 2 and 2 factorial can be cancelled out. So this is going to be x minus 1 squared. Then minus 3 factorial is 3 times 2 times 1. So this cancelled out. So negative x minus 1 cubed. So this is 1 minus x plus 1 plus x minus 1 squared minus x minus 1 cubed. Okay. So this is going to be simplified as 2 minus x plus x minus 1 squared minus x minus 1 cubed. And that's p of 3 of x. And this is p3 of x, p3 of x. Okay, but then we're curious of knowing p3 of 2, so plug it in 2 for x. 2 minus 2 plus 2 minus 1 squared minus 2 minus 1 cubed. This cancelled out. So it's going to be 1 minus, this is also 1, so which is 0. So the answer for this question is E. Okay, this question has to describe the following two series. Okay, the first one let's look at. The first one is k equals 1 to infinity, negative 1 to the k plus 1 over square root of k. So if you want to check whether it's converging absolutely, you put the absolute sign. So it's going to be 1 over square root of k. This is 1 over k 1/2. And if you remember the p-series test, if the p value, which is the denominator power, is greater than 1, it's converging. But this is 1 over 2, it's not greater than 1, it's less than 1, so it's going to be diverging. That means it's going to be absolutely not converging, but we don't know whether it's going to be converging, conditionally converging or not yet. So now let's check whether it's converging conditionally. So it's going to be k equals 1 to infinity, negative 1 to the k plus 1 square root of k. Okay, so absolute, not an absolute value, AST, alternate series test. So it's going to be 1 over square root of k. Is this function decreasing or not? So if it's 1 over 1, 1 over 2, square root of 2, 1 over square root of 3. So if you just plug in the values, you see that it's constantly decreasing, so it is decreasing. So it is decreased. Yeah, I cannot write very well. Decreasing. There we go. And then take the limit of k goes to infinity on 1 over square root of k. This is 1 over infinity, which is 0, which is, 0, right? So that also satisfies. So the series is converging conditionally at least. So this one at least converges. Okay. So let's check the other one. Okay, the second one is k equals 2 to infinity, -1 to the k, ln k over k. So if you want to check it's converging absolutely, take the derivative, take the absolute value, so it's going to be ln k over k. So if you take a limit of k goes to infinity, this is both going to infinity, so take the derivative. This becomes 1 over k over 1 over 1 by L'Hopital. L'Hopital is basically taking the derivative of both sides, both numerator and denominator, so we get not the negative infinity over infinity or 0 over 0. So this is 1 over just k, and limit of k goes to infinity, 1 over k is just 0, right? Right. So, but yeah, we don't have to take the infinity actually. We just have to check whether it's 1 over k is converging or not. And if you remember, 1 over k is p-series test. So since the denominator power is k to the 1 power, so this is going to be diverging, because the p-series test says denominator power p has to be greater than 1 in order to converge, but this is not the case, so this is not going to be absolutely converging. So D, E are not right, B is also not right, and A is also not right. Okay, so it's going to be either C or, actually C is not also right, because, because it doesn't converge absolutely, which it's not right, and it's also, it's also not diverging, because one of them converges conditionally, so this is also not right. Diverges, no. So I know for sure the answer is going to be F, but let's check. Okay, so it's going to be -1 to the k, ln k over k, and we want to check it's conditionally converging or not. So take alternative series test. This is going to be ln k over k, and limit of k goes to infinity, ln k over k goes both to infinity over infinity, so take the L'Hopital. So by the L'Hopital's rule, this is going to be 1 over k, because we got the L'Hopital at the same time. And then if you look at the 1 over k, limit of k goes to infinity, this is going to be 0, which is not less than 1, but which is 0. And alternate series test tells you the limit of k goes to infinity, it has to be 0 in order to converge. So that's right. And let's check 1 over k is decreasing or not. 1 over k, if you plug it in k equals 1, then it's going to be 1, k equals 2, 1 over 2, k equals 3, 1 over 3. So if you see, if you constantly put the bigger numbers, it's going to be eventually go to 0, so it's going to be decreasing. So we know that this is decreasing, so decreasing and limit of k goes to infinity equals 0, so it is converging by alternative series test, and it's going to be conditionally converging, because we checked the absolutely converging and it was not converging absolutely. So that's why the answer is F. Okay, this question has 2 of this series converges and 2 diverges. Which 2 converge? Okay, let's try for the first one. So the first one says 1 over 5th k to the 4th plus 1. So this is same as 1 over k to the 4 over 5 plus you can write it like that, right? So it's this, but once the limit goes to infinity, right? So k equals 1 goes to infinity. I should probably write it before I put 1, right? Yeah, let's do that. K equals 1 to infinity. So this is basically same as 1 over 5k to the 4th power, because if it goes to infinity, this plus 1 will be so significantly small that it doesn't be mattering. So this is just 1 over square root of k to the 4th out of the 5th root. So this is same as 1 over k, 4 over 5. Since 4 over 5 is not greater than 1, which is less than 1, right? So it's going to be diverging by the p-series test. And the p-series test says the denominator power has to be greater than 1. So this is not right. Right? So this is not going to be converging. That means B, C, D are not the right choice. Okay, so we got 3 out the way. So it's going to be 2, k equals 1 to infinity, k to negative e. So this is same as 1 over k to the e power, and e is around like 2.7, and this is greater than 1. So it's going to be converging by p-series test. So 2 is right. I circled it. Oh, I circled 1. I shouldn't have. So it's going to be either A or F, so it's not going to be E. Okay, let's try third one, 1 over k ln k squared. So since I see ln k and 1 over k, and I know that the ln k derivative is 1 over k, so I'm going to use the integral test. So it's going to be 2 to infinity, 1 over k ln k squared dk. Let's put u as 1 over ln k, and du becomes 1 over k dk. So 1 over k dk can be written as du over u squared, because ln k is, u, so u squared, and this is going to be ln 2 to infinity. So this is u minus 2 du, right? So the integrating, if you integrate the u minus 2, this is going to be negative u minus 1 ln 2 to infinity. So this is going to be negative infinity plus 1 over ln 2. So this is going to be 0. So it converges to 1 over ln 2. So it's going to be converging. Okay. So 2 and 3 is converging. So that means the answer F is right answer. But I'm going to go over 4 just in case. So one thing that you have to keep in mind is 1 plus 1 over k to the k of k equals 1 to infinity. This is not a sequence. So some people might think, oh, this is just E, right? But like, no, that's not E. Because if it's like a sequence, then it would be E. But if it's like a series, then it's not a E. So then how would you solve it? So let's put y, some kind of y equals 1 over k to the k power. If you take the ln of on both sides, this becomes ln y equals k times ln 1 plus 1 over k. This k, if you take ln, this k comes down, which is y. This becomes k times ln 1 plus 1 over k. Right. I'm just going to erase it because I didn't put ln on both sides, and I wanted to keep it like that. So I just put ln on one side just to explain you why the k comes from. So that's that. And then you can write this as ln 1 plus 1 over k over 1 over k to make it in the format of L'Hopital. Because we know that if you put k goes to infinity, this is going to be infinity, so it's going to be infinity, and infinity form. But we do want to see whether it's converging or not, so that means you have to use the L'Hopital. So let's use that. L'Hopital, ln of 1 plus 1 over k. So this is going to be 1 over 1 plus 1 over k times k, negative k, minus 2 over 1 over k, derivative is going to be, this is k minus 1, so it's going to be negative k minus 2. Oh, this canceled out. So eventually all we left is 1 over 1 plus 1 over k. This is 1 over k plus 1 over 1 over k plus 1 to the over k. So this is basically same as 1 divided by the reciprocal of this. 1 multiplied by the reciprocal of this. Sorry, so this is going to be k over k plus 1. So k over k plus 1. So we have that. And if you take a limit of k goes to infinity, this is 1. So by the divergence test, which we barely use, by the divergence test, this 1 is not equal to 0. So that means it's diverging. So the 4 is diverging. So the answer is F. Okay, this question is according to a Taylor remainder theorem, the approximation has an error equal to. So Taylor remainder theorem says Rn of x is equal to Fn plus 1 c x minus a n plus 1 over n plus 1 factorial. This is just the equation that we are given, that we have to remember. And we know that order is 2, so then n is 2. So this is going to be the f third derivative. at point C, x minus pi over 6, because a is pi over 6, m plus 1, so it's going to be also 3 over 3 factorial. Okay, we know that. Cool. And let's find the f third derivative. So f of x is apparently cosine of x, because they didn't say what is f of x, but we know that it's cosine of pi over 4 is about this like value, so that means our actual f of x is cosine of x, and we're evaluating the point x at pi over 5. That's the part that we are given this here. So let's say f of x is cosine of x, and let's take derivative. F prime of x is negative sine x. F double derivative, the second derivative would be negative cosine of x. F triple derivative is going to be sine of x. Right. So, and we're evaluating at f third derivative as c, so it's going to be sine of c. Cool. So this is going to be sine of c over 3 factorial, and then we said that x is going to be pi over 5 because that's what they're given. So pi over 5 minus pi over 6 to the third power. Okay, so this is going to be sine c over 3 factorial is 3 times 2 times 1 times pi over 5 minus pi over 6 to the cube. So this is going to be sine of c over 6 times least common denominator of 30, so 6 pi minus 5 pi to the cube, which is same as sine c over c pi over 30 cubed. So that's this one. Okay, so the answer is F. Okay, this question has to use the ratio test to find the series is converging or not. Okay, so let's see. So we have the ratio test, and actually we can cross out some of the things, right? The ratio test said if r is less than 1, then it's going to be converging. So this is not going to be the right statement. C is not the right statement, and D is also not the right statement because it's not saying converging. And F is going to be inconclusive if R is equal to 1, so it is also not right. So that means A is also not right, inconclusive, and R is greater than 1, then it's going to be diverging. Okay, so it's going to be either B or E. Let's try the ratio test now. So k equals 1 to infinity, k factorial squared over 2k factorial. So the ratio test basically tell you to do k plus ak plus 1 over ak. So meaning you have to do k plus 1 instead of k for the first term, k plus 1 factorial, and this entire thing squared over 2k plus 1 factorial, and then divided by the original, this. So this is going to be k factorial squared over 2k factorial, and limit of k goes to infinity. Okay, limit of k goes to infinity. This is going to be k plus 1 times k plus 1 times k factorial squared. I wrote it this way so I can cancel out the k factorial later. So this is going to be 2k plus 2 factorial times 2k factorial. So k factorial squared will be cancelled out. So this is limit of k goes to infinity, k plus 1 squared over 2k plus 2 times 2k plus 1 times 2k times 2k factorial times 2k factorial, right? So this cancelled out. So all we left with limit of k goes to infinity. This is going to be k plus 1 squared over 2k plus 2 and 2k plus 1. Okay, so this is limit of k goes to infinity, k squared plus 2k plus 1 over 4k squared plus 6k plus 2. So the highest term is the one that only we care, because if k goes to infinity, this term will be just minimal and so trivial and so small. so we don't really care. So all of the highest term is k squared, so they are both cancelled out, so it's going to be converging to 1/4, which is less than 1, so it's going to be converging. So then our answer choice is B. That makes sense. Okay, this question has to determine the radius of convergence for the power series. Okay, so I see the k power on top, so I'm going to use the ratio test. So it's a k plus 1 over a k of limit of k goes to infinity, absolute value. So it's basically saying instead of k, we're going to put k plus 1, so 3x plus 2, k plus 1 over k plus 1 divided by the original, so basically multiplying by the reciprocal. So this is going to be 3x plus 2k over k of limit of k goes to infinity. So this says k and k plus 1, if it goes to infinity, it's going to be 1, right? 2 cancelled out, so this is going to be 3x plus 2, k plus 1 over 3x plus 2, k. So this is same as 3x plus 2 to the k power times 3x plus 2, right? I just separated into two terms, and then this is going to be 3x plus 2k, so this cancels out. So this is going to be 3x plus 2. So if you want to check the radius of convergence, so this has to be less than 1. So this is going to be 3x plus 2, bounded from -1 to 1. Subtract both by 2, so it's going to be -1 to -3. So x is -1 to -1/3, right? But when you're checking the radius of convergence, it's basically the endpoint subtraction. So it's going to be the bigger one, -1/3 minus -1/2. So this is going to be 2/3 divided by 1/2 divided by 2, which is multiplied by 1/2. So it's going to be 1/3. So the answer of the radius of convergence is D. Okay, this question asks to find the sequence of tangent 1/k to minus secant of k over k squared plus 1. So this is the sequence. So limit of k goes to infinity of tangent 1/k minus secant k over k squared plus 1 and bracket. Okay, so if the limit of k goes to infinity, this is going to be tangent of 1/infinity minus secant of infinity over infinity squared plus 1, right? But before we actually do that, so this can be simplified into 1/k, right? Because if the k goes to infinity, the plus 1 will be so trivial, so we don't have to really care about. So this is going to be secant of k over k squared, and k over k squared is simplified as 1/k, and you can put k as infinity, so it's going to be 1/infinity. So this is tangent of 1/infinity, which is 0, minus secant of 1/infinity, which is also 0. So it's going to be 0. Okay. So tangent of 0 is 0. So secant of 0 is going to be -1. So it converges to -1. So the answer is A. Okay, this question asks to find the closest value of k equals 1 to 19, -2/3 to the k power. Okay, so this is a partial sum question of geometric series. Partial sum geometric series. Okay, so k equals 1 to 19, -2/3 to the k power, and geometric series partial sum says s of n is same as a of 1 minus rn over 1 minus r. Okay, so our r is -2/3, and a is the first term, which is -2/3 to the first power, so it's going to be -2/3. So s of 19 is equal to -2/3, 1 minus -2/3, 19 over 1 minus -2/3. Okay, so this is same as 5/3 in the denominator, and you can distribute -2/3 in both terms, right? This becomes -2/3 minus -2/3 to the 20 power. So we know that negative 2 over 3 to the 20 power is approximately 0.0003, right? So since we know that negative 2 over 3 to the 20 power is going to be the same, because we know that negative, even though there's a negative sign, negative 1 to the 20 power is just 1. So it wouldn't matter. So this value and this value are going to be the same. So this is just same as negative 2 over 3 minus 0.0003 over 5 over 3. Okay, I'm going to write it as negative 2 over 3 minus 0.0003 multiplied by the reciprocal of this. So this is going to be 5 over 3. 3 over 5. Okay, let's do the calculation now. So this is going to be negative 2 over 3 is approximately negative 0.6666, and negative 0.6666 minus 0.0003 and multiply by 3 over 5. So this is going to be negative 0.6669 multiplied by 3 over 5. So this is going to be 0.6669 times 3. So this is going to be 7, 18, 20, 20, so 20. 2.0.00 negative 2.0007 divided by 1 over 5, I guess. Divided by 5. So you divided 2.0007 divided by 5, 0.4, 20, 0.015, 24. So around negative, so it's going to be around negative 0.40014. Okay, let's find the closest value. So negative 0.40014, right? 40014. So the value is approximately close to C, right? Because right, yeah, because this is value is same as 0.4. Okay, let's write it down. Negative 0.40014. So it's not going to be A, it's not going to be E or F, it's not going to be B, it's going to be either C or D. But if you look at your option very closely, it's 0014. It's not 4011. So this is closer to the option C. So the answer is C. So for this question, you just have to do calculation and see the closest value that you got. Because since we don't have the calculator during the exam, you just have to manually calculate it and see which value is closest. So there you go. So the answer is C. Okay, this question asks to evaluate the statement. Okay, this is like the statement that you just have to remember it. So when the sequence diverges, then series diverges, not the other way around. So you have to find the one sequence diverges. I'm gonna write sequence not one as like the Greek or Romanian number one, because I'm gonna actually just write it down the fact. So one sequence, I spelled it wrong, sequence too. Sequence diverges, then series diverges, and also series converges. Then we know that sequence converges. We just have to find that there's two facts, not the other way around. So this question is basically asking, do you remember the simple facts of sequence and series diverging? So the series diverges. Let's find that series converges. My bad. Series converges and the sequence converges. Okay, the second one is 3. So that is going to be 3. 3 has to be included. So not A, not E, not F. And the sequence diverges. So sequence diverges and the series diverges. Okay, so 2 and 3 are the right statement. 2 and 3 are the correct statement. So that means the answer is D. So You just have to remember these two facts. So the answer is D. Okay, this question asks to find a formula for the nth partial sum and use the hint partial fraction. Okay, so let's do that. So Sn is Sn is equal to k equals 1 to n, 1 over k squared plus 5k plus 6. And if you decompose the k squared plus 5k plus 6, this is same as 1 over k plus 2 and k plus 3. And we want to separate into two terms. So this is going to be a over some kind of constant a over k plus 2 plus b, some kind of constant b, over k plus 3. So we want to find this equal to each other. We want to find the value of a and b when these values are equal to each other. So let's multiply k plus 2 and k plus 3 on both sides to get a and b value. So this is going to be 1 equals a k plus 3 plus b k plus 2. Let's plug it in k equals -2. So this becomes 1 equals a, right? K equals -3. Then 1 equals 0 minus b. So this is b equals -1. Some might wonder why did you get 1 equals a, because if I plug it in k equals -2, this just becomes 0. And same thing in here, k equals -3, this k plus 3 becomes 0, which is why you get b equals -1. So a is 1 and b is -1. So this is basically saying k equals 1 to infinity of 1 over k plus 2 minus 1 over k plus 3. So let's plug it in now. Let's k equals 1, then this is 1 over 3 minus 1 over 4. K equals 2, then it's going to be 1 over 4 minus 1 over 7. So we see the pattern now. So this is going to be, this term will be constantly cancelled out, right? So we know for sure 1 over 3 will be our first sum. So this is going to be e, and that is going to be exclusively only going to be e, right? And the canceling terms happening around -1 over k plus 3 in here, right? In this value. So that means this term will be just going to be 1 over 3 minus 1 over k plus 3. I can explain it again. Yeah, sorry. I'll just go back. So if you do the cancellation, this is the telescoping series, and it will be eventually cancelled out with just the last term in here left, and the rest will be cancelled out. So yeah, I'll just explain it again. Sorry. So 1 over 3 minus 1 over 4 when k is equal to 1. K equals 2, 1 over 4 minus 1 over 7. K equals 3. This becomes 1 over 7 minus 1 over, not 1 over 7, sorry. 1 over 5 minus 1 over 6. And k equals 4. This is going to be 1 over 6 minus 1 over 7. So you see this will be eventually cancelled out. And I wrote this part wrong, didn't I? Yes, 1 over 5. So this part will be cancelled out, this part will be cancelled out, this part will be cancelled out. So if you do the nth term, the term that would not be cancelled out would be this term, and the very last term in minus 1 over k plus 3 term. Which is why this is going to be, the first term will be remaining, so 1 over 3, and the very last term when k is 1 to, not infinity, k is 1 to n, so this is going to be -1 over n plus 3, which is why this is going to be, if you add all those terms, 1 over 3 minus 1 over n plus 3, because the rest middle terms will be just cancelled out. And the telescoping series cares about the end points, so make sure whether end points are cancelling out or not. Which is why the answer is, as we expected, E. Okay, this question asks 2 of the series converge and which 2 of the series converging. So let's try the first one. So the first one is e to the k over e to the 2k plus 1. It's k from 1 to infinity. And this is using the direct comparison test, e to the k over e to the 2k. This is the same as 1 over e to the k, so which you can group it as 1 over e to the k power, which 1 over e is 1 over 2.7, which is less than 1, so it's going to be converging. And we know for sure, and also if you compare it, this value is bigger value because there's plus 1 added. So this is the bigger one, and bigger one converges, that means smaller one also converges. That means one is converging. So this one is converging. So it's going to be A, B, C option. D, F cannot be the answer choice. Let's try 2. Negative 1 to the k, k plus 1 over k. Since the series are, the signs are alternating, so you're going to use AST, alternative series test. So this is going to be k plus 1 over k. And limit of k goes to infinity, k plus 1 over k is 1. This is not equal to 0, so it's going to be diverging. Okay, 2 is not right. That means A is not right. Okay, 3. 3 is pi k over 3k minus 2. Let's do the direct comparison test again. Direct comparison test, pi k over 3k. Okay, this can be grouped as pi over 3k, and then pi k over 3k minus 2. Since this term is bigger, okay, right? So the numbers are like subtracting each other, so this term is bigger, and also pi over 3 is 3.14 divided by 3, which is bigger than 1, right? So that means this is going to be not converging but diverging, and this is the smaller one diverges, and the bigger one also will be diverging. So by the direct comparison test, this 3 is not right. So we know for sure C is going to be the right answer. Okay, let's try it though. So the fourth one, 1 over ln k to the k power. Okay, I'm going to use the root test for this one, because I know I can cancel out the k. So let's do that. 1 over k ln k to the k power, cancelled out. So this is going to be 1 over ln k, and limit of k goes to infinity. 1 over infinity is 0, which is less than 1. So by the root test, it converges. So the answer is C. Okay, this question asks to use the limit comparison test to draw appropriate conclusion. So let's do that. So the limit comparison test said to find the similar term looking like that. K equals 1 to infinity 1 plus k over square root of 3 plus 3k plus k cubed. So you have to find a similar one. So I'm gonna do, what we have to do is find the highest power in the numerator and the denominator and write it down. So that's gonna be k for the numerator, and the k cubed square root, it will be the denominator highest power. So let's compare those two, and this is same as k over k to the 3 half, so which is 1 over k 1 half. So we're gonna be comparing with this two, so it's gonna be A, D, F will not be your right answers. So it's gonna be either B or C, and let's see. 1 plus k over 3 plus 3k plus k cubed, and comparing with 1 over k 1 half. I'm so sorry about the background. I can control my neighbors. So since the terms are added more in the denominator, that means this one, right? Oh wait, this is not actually the direct comparison test. I'm sorry, we are comparing with the limit comparison. I forgot. So this is going to be comparing with 1 plus k, square root of 3 plus 3k plus k cubed divided by 1 over k 1 half power. So this is going to be 1 over k 1 half, right? Right? So this is going to be 1 plus k 1 half over square root of k cubed plus 3k plus 3. This is k 1 half plus k 3 over 2 over square root of k cubed power plus 3k plus 3. If the limit of k goes to infinity, all we have to care about is the highest power, so which is k 3 over 2 power and k cubed square root, which is same as, this is going to be eventually same as k 3 over 2 over square root of k 3, right? This is same as k 3 over 2 over k 3 over 2, which is 1. So since this is greater than 0, this is saying basically limit comparison tells you that it's going to be either both converges or diverges. But if you look at our 1 over k 1/2, it's by the p-series test, it's going to be diverging. Test diverges because 1 over 2 is not greater than 1. So it's going to be diverging. So that means our answer choice C is the right answer. So the answer is C.